to do today is I want to finish talking about a few things from 5.1. Okay? Yesterday we talked about properties of exponents, right? And scientific notation. Okay? So I just want to show you a few things about scientific notation. You may already know this, but you may not know this. We did get our new microphone, so if you're listening to it on YouTube, it should sound a lot better. I'm not sure how good it'll sound because that class is being very loud. No, the school bought it. So, let's talk about, for a second, let's just talk about scientific notation. Now, I want to show you how scientific notation relates to what we've been doing. What if I said, what is 2x to the third times 3x to the fourth? Could you do that? Pardon me. Oh, pardon me. All right, so tell me what you would do. Okay, 2 times 3 gives you, and then, yeah, x to the third times x to the fourth is x to the seventh. Very good. So let me show you how that applies to scientific notation. What if I had 3.4 times 10 to the fifth times 9.1 times 10 to the negative second? Okay? First question. Which one of these is a larger number, the left one or the right one? Very good. Okay. You're going to use the same skills that you used up here, guys. You're going to use those skills right here. All right? So what are we going to do?
Multiply 3.4 and 9.1.
That's exactly right. You're going to multiply 3.4 times 9.1. Somebody get your calculator and tell me what that is.
30.94.
30.94 times 10 to the, now what are you going to do? Yeah, you're going to add your exponents, guys, just like we did up here. What's a 5 and a negative 2? 3. Okay, so this is the answer. Is this a good answer? Why? All right. This number right here, y'all, if you left that answer like that, I would mark it wrong. This number to the left has to have only one digit to the left of the decimal place. Remember how we talked about him when we said A has to be greater than or equal to 1, but less than 10? You can't have 2 digits to the left of the decimal point. Okay? So we have to move the decimal point 1 place and call that 3.094 times 10 to the, very good, 4. Now, anybody in here go, ooh, I moved it 1 place, I don't know, am I supposed to add the 1 or subtract the 1? Anybody have a difficulty with that? Okay, I do too. It's okay. It's not a big deal. So I'll show you a crazy way to remember, okay? Because this morning, one of the other classes, Kayla said 4, and I looked at her like she was crazy, and then someone else said 2, and she was like, oh, I got it right. I mean, wrong. And then she got it right, and I was like, yeah, I looked at you like, and she said, yeah, you looked at me like I was wrong. And I said, because it just doesn't come naturally to me. I just have to think about it. And here's the way I remember it. Have you ever heard of Los Angeles? Okay, so L.A. All right, in the alphabet, it goes L-M-N-O-P-Q-R-S. R-S. So when you go left, you add, and when you go right, you subtract. Okay? So it's kind of just an easy way to help you remember. When you move it left, you add. So however many places you go left, you add those places to this number. When you go right, it makes you subtract. Okay? All right, so if you had 0.0012 times 10 to the negative third, could you write that in scientific notation? So what's A? 1.2 times 10 to the, you went to the right, so 3 places. What do you have to do with that? What's negative 3 minus 3?
-6.
Very good. Okay? Now listen, here's the even better part of all this. Will my calculator do all this for me? Yeah, people. He'll do every bit of it for you. Okay? So let's learn how to use it because we're going to use our calculators on our test. But look, it's nice to know what you're doing. In kindergarten, they don't hand a kid a calculator and say, here, let me show you how to add and subtract, right? They teach you how to add and subtract, and then later on they let you use the calculator. So, take your calculator. We'll do this one, 3.4 and 9.1. So, first of all, I'm going to take my calculator and press the mode button. You'll notice that it's if you reset your calculator, its default mode is in the normal mode. Y'all, this is called decimal. The decimal mode. That's normally what we express numbers in. Okay? Just to the right, this is scientific mode. So if I press enter, it's now in the scientific mode. Does anybody know what E and G means? Yeah, a lot of kids will say that's English. No, it's not. It's engineering. Okay? It's engineering. Am I an engineer? No, I'm not, people. I have no earthly idea what it does. Okay? I'm not an engineer. I majored in math. You wouldn't want me to be your engineer. Okay? I might ask my husband what it means because he's an engineer, but I don't really know. So you'd have to find that info somewhere else. So this is scientific notation. Now, whenever you put something in there, like if we did that one that we just did, 0.00012, and we even said times 10 to the minus 3, right? Yours will pop it up there, mine won't. And then if I press enter, you can see that, oh, it must have only had 2 zeros, sorry. I'll go back and get rid of one of the zeros, so it's the same. Oh, crud. I hung it up. Ah. One of the bad problems about this thing, it won't even shut down now. Dadgummit. I'm going to pause it for a second. Okay, so we went back and fixed it. This is like the one we saw on the paper, and there it is right here. Now listen to me. Let me make you understand this. If you write this on your paper, I will count it wrong. Every stinking time. Yeah, that E right there means times 10 raised to this power. So on your paper, you have to write 1.2 times 10 to the negative 6. If you write this, I will not give you credit for it. Okay? Now, could we have done one like the first one that we did on our paper? Could we have done one like this right here? Yeah, watch this, 3.4 and 9.1. So, I'm going to show you how to do that. 3.4, I'm going to show you this way, sorry. Instead of, could I put times 10 to the 5th power? Yeah, but the calculator uses this E right here as times 10. Is there an E somewhere on my calculator I could use? Very good. Right above the comma, it has a double E, so you can go second and comma, and it'll put it in there. And then ours was times 10 to the 5th. You can close the parentheses, open them again. What was it, 9.1? Times 10 to the what? Negative 2. Close it. And notice that it gives it to me in proper scientific notation. So 3.094 times 10 to the 4th is what you would have to write down on the paper. Anybody got a question? No, you don't have to use the E, but you can use the E. Okay? But you cannot write the E on your paper. Okay? If you write this on your paper, what it says to me is that you don't know what that E means. Okay? And so you just wrote down what your calculator said. Alright? So, I'm not going to give you credit for it. Alright, anybody got a question about scientific notation? Should you miss any scientific notation problems? Oh, my word. Come on, people. You're using the dang calculator. Alright, so let's try 2 more, and then we'll move on to section 2. The first one I want you to do is this. I'm just going to try to share with you some hints of ways that I think keep kids from making mistakes. All right. Now, I'm going to be a little bit of an English teacher right now, okay? I'm going to say normally I would tell you to make all your negative exponents positive, collect everything together, and then start canceling stuff out and reducing your fraction, okay? That's my normal way to do things, is to make all my negative exponents positive, move them, okay, collect anything that's alike, and then the last thing I'm going to do is start reducing stuff. I'm not going to go here and the first thing I do is start slashing stuff out of my problem. Now, why do I choose to do this one differently? No, what can I mean, what? What is this, guys? It's the same thing. Anything over itself is what? 1. So, I mean, why would I not do that? You see what I'm saying? If something's like jumping out at me, then I can do it really fast. If this were a 4 and this were a 5, would I have done that? Oh, no, no, no. I wouldn't have done that. I would have moved something. Okay? So, now you're ending up with 16m to the 4th over 2. Can I reduce it some more? Yeah. The 2 and the 16. 2 goes into 16 8 times. And my answer is 8m to the 4th. All right? Anybody got a question? Well, I hope it is, but look, I'm just going to tell you this. There's lots of places on this test where you're going to have to be careful, okay? And now, I've already told you on the worksheet, if you've started working on the worksheet, you've already seen that those problems can be a mess, all right? That's why I want you to have some time in class. But now, look, I'm going to tell you that this is my order. The first thing I'm going to do is I'm going to make negative exponents positive. Okay? In other words, I'm just going to move them. The second thing I'm going to do is I'm going to collect like terms. Okay? And that, look, this is what that's using. Positive mental attitude during school. Okay? Powers to powers, you multiply. When you multiply, you add. And when you divide, you subtract. That's what you're using when you collect these like terms. Okay? The last thing I'm going to do is, I don't know, you can call it whichever you want to. You can call it canceling. You can call it reducing. It's all those things. The last thing I'm going to do is cancel and reduce, whatever. Okay? All right. Everybody okay so far? All right. Here's one more. Let's do this one. This is example 4. I'm going to change it just a little bit. This is a different problem from what we did the other classes, but I think I'm going to like what this one does better. Okay, so let me just ask you some questions. Can I just take this x to the minus 2 and put it down here? Why? Okay, y'all, order of operations. Y'all, he's in parentheses. You have to raise him to that third power first. Okay, so everything in the parentheses gets raised to the third power. X to the minus 2 raised to the third is x to the what? Perfect. Powers to powers, you multiply. Y to the third raised to the third is y to the over. Didn't have to do anything down here. X to the 4th, y to the 7th. Okay, now what am I going to do? Okay, now I'm going to make those negative exponents positive. So this is the only thing that moves. He moves to the bottom. Multiplication is commutative, so it doesn't matter whether you put him. Some kids will put him after the x to the 4th. Some kids will put it before. It doesn't make any difference. But now I'm going to collect all my like terms. So y to the 9 on the top. On the bottom, what is? X to the 4th times x to the 6th. X to the 10th. And then there's my y to the 7th. Now, can I do anything with it, or am I finished? Yeah, I can reduce those y's, guys. How many y's can I take out? 7 of them. So remember how we talked about this yesterday? 7 of them, and they're all gone. Do not just cross that 9 out. Right now, it's not that bad, but when you put x's and y's and z's and a's and b's and c's in there, then that 2 gets very confusing. You don't know who he belongs to or if it's just a regular 2. So go ahead and cross the whole thing out and write y squared. Now, what's the only thing left on the top? Y squared. And what's left on the bottom? Perfect. And that's my answer. Okay? Anybody got a question? All right. So let's move on to 5.2. 5.2 is evaluate, which we're not even going to get to today, and graph polynomial functions. All right. So the first thing I want to do is I kind of want to talk about what's a polynomial function. A polynomial is a monomial. Come on, 10. A monomial. What does mono mean? 1. What does poly mean? Many. Okay? Very good. So let me just make sure it's good. Okay, so he's a monomial or a sum of monomials. So it's either one term or it's a whole bunch of terms. That's all that's saying. Okay? So a monomial or a sum of monomials. Okay? Now, I'm going to take just about 3 minutes and I'm going to write the horrible mathematical definition of a polynomial function, just in case your professor in college decides to bring it out and scare you with it. Now, y'all, have we looked at polynomial functions before? Here's one right here. That's a polynomial function. Okay? What do we call it? What kind? A quadratic. Okay? It's a quadratic. Now, I could use A's, B's, and C's to define this polynomial function, but how many letters are there in the alphabet? 26. So now I've restricted myself to only have 26 terms, right? And poly means many. It doesn't mean many up until you get to 26. It means as many as you want to have. So it could have 1,000 terms if we wanted it to. Okay? So we don't want to restrict it that way. That's why we're not going to use A, B, C, D, E, F, all that kind of stuff. All right? Let's talk about one more thing. What are these little numbers down here called? Subscripts. Subscripts. Okay? And what is it, why am I putting these subscripts? What do those subscripts tell me about these X's?
They're all different.
Yeah, they're all different. This one is different from this one, is different from this one. It just means that they're all different. So I could use the same letter, okay, but it could mean all different things. Everybody agree with that? Okay, you've seen them in the slope formula. If I was talking about points and I had a y sub 1, I would know that this x sub 1 went with that y sub 1, right? Okay, so subscripts. That's what this is going to use, all right? So here we go. Write the definition. Can it be crazy? You don't have to know it, okay? I just want you to see it. So, a sub n, x to the n. Now, what is n? It's just a number, people. Any number in the world, all right? Now, when we write a quadratic in standard form, what kind of order do the powers go in? What do they start with? X squared, and then what does it go? X to the first, and then there's not an X. That's an X to the 0. There's not one. Okay? So they go in descending order. You agree with that? All right, so that's where these things are going to come from. Watch what's going to happen. A sub n x to the n plus a sub n minus 1 x to the n minus 1. I just went down 1. Plus a sub n minus 2 x to the n minus 2. Plus a sub what? N minus 3 x to the what? Now we could do this how long? Forever, people. You could do it forever, okay? So we're going to have to find some way to close this thing off. So we're going to say plus, and then we're going to say dot, dot, dot. And that dot, dot, dot just means it goes on as long as you need it to go on, okay? But eventually, you're going to get down to something like this. A sub 3 x to the third plus a sub what? 2 x to the second plus a sub 1 x to the first plus a sub 0, and y'all look, x sub 0. But what is x to the 0 power?
1.
So this one's not there. That's just my constant. Okay? That's what the definition of a polynomial function looks like. Kind of crazy looking, isn't it? Okay, so let's talk about some definitions. Now listen to me. Remember the last test when I told you there's going to be like 3 or 4 questions, and you're going to have to tell me what the discriminant is and tell me what describe the nature of the roots. Do you remember me telling you that? Did you know that 1/4 of the kids couldn't tell me what the discriminant was and had no earthly idea about the nature of the roots? Now, does that sound crazy to you? Y'all, I just don't get that, okay? I told you it was going to be on the test, and it was an easy question. But they did all kinds of crazy stuff to it, okay? Oh, there's the boy you're fixing to tell a story about him, all right? So I'm telling you that you better learn these definitions, okay? You better, I'll tell you just a sec. You're going to learn these definitions because we're going to ask questions about it on the test. Okay, so first thing we're going to talk about is a leading coefficient. A leading coefficient. Now, what do you think a leading coefficient is going to be? Where do you think it's going to be? In the front, because that's why they call it a leader, right? The leading coefficient. But it's only in front if it's written in standard form. Very good. Which means that you have to start with the what? Highest what? Exponent. Okay? So the leading coefficient is actually the coefficient of the highest exponent. Okay? The coefficient of the highest exponent. Now, why do they call it a leading coefficient? Because, y'all, when it's in standard form, he is the leader. Okay? He is the leader. All right, so here's my story. When Tanner was like 4 years old, we went to the Smoky Mountains. All right? That's where that picture came from right there. We were on our way home, and we were on the interstate, I don't know, somewhere in Georgia or something, and all of a sudden Tanner starts squalling. He's just bawling, crying. All right? I'm like, what in the world? I turn around and I go, what's the matter? And he said, why can't we ever be the leader? I'm like, what? And he goes, well, we never get to be the leader. I'm like, we're on the interstate, Tanner. You don't get to be the leader on the interstate. It's like every time we pass a car, there's another one up there, and I want us to be the leader. So he thought he could be the leader, but not in standard form, and I'm not on the interstate. All right? Now, do you think they're going to make this tricky for you? Yeah. Watch this. 2x plus 5x to the 4th minus 4x squared plus 3x to the 5th minus 1. This is my polynomial. Okay? Can you tell me what the leading coefficient is?
3.
Everybody see it? Now, what if someone wrote 3x to the 5th? Is that right?
No.
Y'all, that's not a coefficient. That's the whole term. And it's not right. It won't be counted right. Okay? Is that a hard question? Tell me what the leading coefficient is? That's a present, guys. You look at the highest exponent, and you go, I'm going to pick the number in front of him. Okay, let's learn another definition. The degree of the polynomial. Okay, degree of the polynomial. The degree of the polynomial is the highest exponent.
So if it's 5, it's like that equation would be 5. The leading coefficient. What if you had like plus 3x to the 5th, how plus 3x to the 4th?
It would, oh, it'd still be 3. It'd still just be 3. Yeah, I'd just say, well, you got an opportunity to get it right, even if you guess the wrong one sometimes. Okay? So, just bettering your odds for you, but it is just the coefficient. But y'all listen to me. Does it include his sign? If this were a minus 3x to the 5th, could you just put a 3? What would you have to put? Negative 3, minus 3, okay? So, the degree of the polynomial is the highest exponent. What's the degree of this polynomial? Yeah, 5. What's the highest exponent, people? 5. So that's the degree of the polynomial. It's a 5th degree polynomial. Okay? A 5th degree polynomial. Alright, let's talk about a constant. Y'all, a constant is just a plain old number. It has no variable in it. Can you tell me what the constant of this polynomial is?
-1.
Very good. Alright, so listen guys, these are going to be questions on your test. I'm going to give you a polynomial, okay, and I'm going to ask you these things right here about it. That's not very hard, okay? Alright, so let's make a chart. We're going to make a chart. These are common, now this is more definition, alright? Common polynomial functions. Common polynomial functions. There's 5 of them that you have to know. In the first column, I'm going to tell you what degree they are. Now, what does that mean? That's the what? The highest exponent. When I say that, you need to be thinking, oh yeah, that's going to be the highest exponent. Okay? That's going to be what degree it is. The next one is going to tell you its type. It's kind of like its name. Alright? What we would call it. The next one is going to be what it's going to look like in standard form, just a general standard form. And the next one is going to be an example of it. Okay, you ready? The first one's going to be of degree 0. Now y'all listen to me. If 0 is my highest degree, what is it telling me about my x's? There's not any x's, people. There are no x's. It's going to look like x to the 0 power, which is what? 1. We learned that yesterday. Alright, so, you know what we're going to call it? If there are no x's and you have an equation, anybody know what it's called? It's called a constant function. Why? Because that's all you got, right? Just a plain old number. What's it going to look like in standard form? F of x is equal to a. Just a number, people. Just a number. Whatever you want to call it. Your example, f of x is equal to, pick your favorite number. Mine's 5, because there's 5 of us in our family. All right? Unless you talk to Tanner. And once you move out, then he says you're not part of our family anymore. I don't know. I guess he disowns you. So we'll be long and we'll be disowning him. Okay? So the next one is degree 1. That means I'm going to have an x to the first, and that's going to be the highest exponent. Okay? Now, what would that look like if you graphed it?
That's a linear.
That's a linear, because it makes a line, right? See, that makes all the sense in the world. What does it look like? F of x is equal to ax plus b. We're just using alphabet, because we're only going just so far. Okay? Ax plus b. An example, f of x is equal to, pick your favorite slope, times negative 1/2, times x, and then plus 3.
Because it's like a slide.
Yeah, that's right. And it's not one of those crazy ones either. Oh my gosh. I just broke a fever. All right. Yeah. Yeah. God, can't you see it?
I can see it.
Yeah. I'm like, I had a little fever this morning, but not too bad. Yeah. Yeah. Dude. All right. The next one. Second degree. Oh my word, people. These are your favorites. What do we call them? Quadratic. Draw that cube. Man, I put some little devil horns on that thing. Are we not so glad to be through with that?
Are we ever
Are you really ever through with it?
No.
Yeah. So, quadratic. What's it look like? F of x is equal to ax squared plus bx plus c. People, make you one up. Can I do this one? Negative 2x squared minus 1. Why not? What's b?
0.
0. He's legal. There's nothing wrong with him. Okay? He's good. He doesn't have to have every term, but he could. Okay? What's the next one? 3. This is a third degree polynomial. Now look, if I said x raised to the third power, you would say x cubed. This is called a cubic. Okay? A cubic polynomial. It's going to be f of x is equal to, you ought to be seeing the pattern by now, guys, okay? ax to the third plus bx squared plus cx plus d.
2 means pi, not pi.
Oh, well, and we call, it has two terms. We call it a binomial. But think about this, all right? No, never mind. Don't really know how to do that. All right, I don't know why. All right, so f of x is equal to, I'm going to make me a little pattern. 3x to the third plus 2x to the second plus 1x to the first plus nothing. Okay? And the last one, a fourth degree. Now, what do we call a four-sided figure?
Okay, no. It's 5, I'm stupid. I was good at
Now, a square is a special one. Everyone is called that. That's a special one. Oh my word, people. Good night. Y'all know all, thank you very much. Y'all know all kinds of special ones, but just a general thing. Okay? A quadrilateral. Okay, how many, it takes 4 of these to make $1. Quarters. This is called a quartic. A quartic function. All right, it's the next to the fourth. That's a quartic. Now, let me tell you some of the weird things that have happened. All right, when because these are going to be questions on the test. All right, I'm going to give you a function and say what's its degree, what's its type, and then people are going to try to think of this word right here, quartic, and they're going to put quadratic. I'm like, quadratic? I've never even heard of that. It's quadratic, and this is quartic. Okay, so you can't put them together and make up your own words. All right?
So, isn't that what they did in the beginning?
I guess so, but then we adapted them, or adopted them, or we used them, or whatever you want to say. So, yeah, ax to the fourth, no, plus bx to the third, plus cx to the second, plus dx plus m.
Whoa.
I was just seeing if y'all were paying attention. Okay? All right. So, what's this going to be? This is going to be f of x is equal to, I'm very tired, so x to the fourth.
Okay.
Okay? I'm just tired. All right, so let me show you what a problem is going to look like. Oh, well, first, before I tell you what a problem looks like, let's really go into detail about this polynomial function, because if you've looked at your worksheet,
I've looked at it.
then you might have seen that it has some questions on there, and it says, hey, is this a polynomial function? So let's talk about what a polynomial function really, I mean, we wrote that kind of crazy definition down, but let's talk about what it can have and what it can't have. Okay? First of all, the x must be raised to the 0 or a positive number. Alright? That means it can't be what? Yeah. You can't have it raised to a negative exponent. Now, what does that really look like? Let's talk about what this really means. If you can't have x to a negative exponent, where does that mean x's really cannot be? You don't know? Huh? No? What about this? What if I had 2x to the negative third? Is that a polynomial function? No, we just said it has to be raised to the 0 power, which means there won't be an x, okay? Or to a positive number, so obviously he's out. But what if someone chose to write it differently? What if someone chose to make this exponent positive? Where would you have to put that? Yeah, so it would look like this. Do you agree? Is this a polynomial function? No, because y'all look, if you wrote it up here, what kind of exponent would that have? Okay? So see, what I want you to think about is, even if someone just says x must be raised to a 0 or a positive number, what they're really saying is you can't have a negative exponent for x, which means the x's can't be where? That's exactly right. Can't be in the denominator. The x's can't, that's really what they're saying. They may not just come out and say it, okay, but this is what you can infer from this right here. I can't have any negative exponents. I can't have an x to the negative 2, negative 7, okay, which means I can't have any x's in the denominator. Okay, here's another thing. No x's as exponents. What? You can have an x as an exponent? Yeah, you can have a function that's called 2 to the x. It's not a polynomial function. Guess what it's called? I think this is cool. Exponential. Yeah, Tommy, an exponential. Doesn't that make sense? Of course an exponential would have an x in the exponent. See? That makes all the sense in the world. But it's not a polynomial function, guys. Okay? You can't have that. Alright, so let's work a problem. This is example 1. Oh my word, we learned all that stuff and we hadn't done a problem. Here's what the first thing. Is this a polynomial function? Now, did I just tell you how to tell if it's a polynomial function? Alright, so that's the first thing I want to know. If so, then I want you to, 1, put it in standard form. Now, what does that mean?
Let's see, whatever it is.
Okay, that means you start with the what?
The
Highest exponent, and then you go down. You don't skip around, okay? You don't do all the evens first and then do the odds. You just start with the highest exponent and you go down. All right, that's standard form. The next thing I want you to do, 2. I want you to state the degree. All right, now what is that again? How do I find the degree of a polynomial? The highest exponent. Oh, so we just put him first. That shouldn't be too hard, right? The next thing I want you to tell me is what type is it? What am I talking about? Give me some examples. Quartic, quadratic, cubic, linear, and constant. Okay? Now, after that, they just call it a 5th degree, a 6th degree. Okay? You know what I'm talking about? You know how all the special words for geometry, like they have, triangle, quadrilateral, pentagon, hexagon. That's right. So the dodecagon is your 12, right? Undecagon's 11. Dodecagon's 12. Anything after that is just called a 13gon, 14gon, 15gon. Now, why they made up 12 names and then quit, I don't know. But they made up only 5 here and then quit, so we can be thankful. All right, so tell me what type it is. And then the last thing I want you to do is tell me the leading coefficient. Because he's not on the interstate, and he gets to have a leader. All right? So, here's the first one. H of x is equal to x to the 4th minus 1/4 x squared plus 3. All right. You ready? First of all, you write down, don't say it, write down, is it a polynomial function? People say yes or no question. You got a 50-50 shot if you're just guessing, okay? Don't skip it. Is it? Yes or no? Yes. Very good. There are no x's in the denominator, and there are no x's as exponents. That's what we're looking for, okay? So yes, it's a polynomial function. Put it in standard form. It already is in standard form. Oh, weren't they nice? So x to the 4th minus 1/4 x squared plus 3. Or you could just draw an arrow. Whatever, it's your note. Okay? State the degree. Don't say it. Write it down. What'd you write? Perfect. Write down the type. Don't say it. Write down the type. What's it called? That's what the type is. What would you call this? What'd you call it, people? Quartic.
It was in my head, and then I wrote down something.
Yeah. Sometimes that happens. That's why I told y'all about quadratic. All right? That's a crazy word. I can't even hardly say it. All right. Next thing, leading coefficient. What is it?
1.
Perfect. All right. Okay, here's the next one. Oh, not C. B comes next. All right. I'll try to make the English people happy. Here's this one. Oh, this is supposed to be a square right here. Sorry. Yeah, that would have been kind of hard. All right. Are you ready? Is this a polynomial function? Yes or no?
Yes.
Yes, it is. He meets all the requirements. Can you put it in standard form?
Yes.
What does it say?
Pi x squared plus 7x minus the square root of 3.
Perfect. What degree is this polynomial?
2.
What's it called? Come on, people. You spent 9 weeks on it. Quadratic. What's his leading coefficient? Pi. What's his constant? Negative square root of 3. Very good. All right. We didn't write that one down there, but I could. That'd be a good question. Okay? All right. Here's the next one. You ready? F of x is equal to. Here it is. Is this a polynomial function?
No.
Justify your answer.
There's a negative exponent.
Okay, and you can't just say it's a negative exponent. You have to say x. is raised to a negative exponent. Because what if I had said 5 to the negative 1 x squared? Would that have been legal? Yeah, that would have been 1/5 x squared, and that would have been legal. So you can't just say there's a negative exponent. You can say x is raised to a negative exponent. Could I also have said there's an x in the denominator?
Yes.
Yeah, people, that is 3 over x. It's just another way to write it. Okay? All right, let's do another one. You ready? Are these hard? Okay, please don't be the 1 in 4 that misses this on the test. Okay? I just don't get that. That's okay. Yeah. Don't get that. All right, so here we go.
I came up with something to ruin this.
Okay. Oh.
No.
No.
Get away. Like witches or vampires, like they're repelled by the crosses.
Yeah.
X
So you put an x.
No.
No
Get
x's.
away.
All right, so is it a polynomial, yes or no?
No.
Reason?
There's an coefficient is raised to the
All right, so there's an x as an exponent. Can I say that?
Yes.
Sure.
So if you see me going like, I didn't know how to speak in him.
I know you're telling the answer. You be telling answers. All right. And let's work one more problem and then we'll stop and we'll lack one thing to do tomorrow. Okay? We'll just lack one thing to do tomorrow. So it'll be a little short video. All right. So here's your problem. You should not miss this. Okay? But I want to tell you this. I don't want you to use a calculator. I know on the test I'll let you use a calculator. But today I don't want you to. I want to make a point. So 2x to the 4th minus 5x to the 3rd minus 4x plus 8. And I want you to evaluate it when x is equal to 3. Okay? So go. You got about 2 minutes. What do I mean when I say evaluate it? What are you going to find? F of what? F of 3, which means you're going to plug in the 3 everywhere there's an x and follow the order of operations. Now, I will say this. On a test, what would I probably do? I'd pop this in the calculator, write my answer down, and move along, people. Move along. Okay? But practicing our skills, our math skills, is never a bad reason. Dang it. This is so good.
I think.
Okay, I don't like to subtract, so I'm going to do my positives together, 170, and then do my negatives. You don't have to do it that way, do you? What is 170 minus 147? 23. 23.
I got 30. I messed up on the 5x cube. Oh. I don't know what I did. I was trying to do it in my head.
Okay, so everybody okay with that? All right, tomorrow I'm going to show you a really fast way to do this. Not with the calculator, okay? Not with the calculator, but it's really cool, and it comes into play later on with our stuff that we're going to do. All the fluff and stuff.
Yeah.
Yeah, that's what we do. That's exactly what we do.